In this lesson, we'll be going over UDP, which is a protocol in the TCP/IP suite of protocols. IP is the network layer, and that's the network layer in the OSI 7-layer reference model. The IP network layer carries the IP address, and that has information about how to get packets to its destination. The transport layer sits on top of the network layer, and that carries information about how to differentiate networked applications. That information about how those networked applications gets differentiated is in the form of ports. So the transport layer has ports, and the network layer has, in this case, an IP address. UDP is a transport layer protocol, and UDP stands for User Datagram Protocol. It's often called connectionless or sometimes unreliable. Now, unreliable doesn't mean that you can't trust it at all. It doesn't mean that it's not worth anything. It just means that there's nothing in the protocol that says that it's going to guarantee that the datagrams that you sent are going to get there. So datagrams are sent out on the network with nothing in the protocol at all as a form of safety net. If you wanted to use UDP and you needed that type of safety net, you would have to write it into your application. So UDP is a fast protocol. That's one of the reasons why it's good. It's also one of the reasons why it's unreliable. In order to get that speed, you don't have all of the error checking and validation that messages are getting there. So because it's fast, it's good for things like games and for real-time voice and video. Anything where speed is important, you would use UDP. So right here I've got a packet capture that I took, and I'm going to narrow down my focus here in Wireshark by applying a filter that just says UDP. And now I've got a list of all of the UDP packets that were taken during this capture. I'm going to take a look at just one of these packets here. I've got a UDP packet that originated from my system. We're going to ignore the lower level headers here, the part that says frame and Ethernet 2 and Internet Protocol version 4, and we're going to focus on the user datagram protocol portion of the packet. As I expand that UDP part of the packet, I don't see an awful lot of information here. What I see is just a source port and a destination port and a length. And there's also a checksum. So UDP doesn't come with an awful lot of headers because it doesn't need any. The only thing it needs is to tell you how to get to the application on the receiving host, and that's with the destination port. And once the message gets to the destination needs to know how to communicate back to the originator, and that would be through the use of the source port. A return message would convert the source port to a destination port and send back to that port in order to communicate with the originator. So we have a source port and a destination port. The length is a minimal amount of checking to make sure that if the packet that you received is different from the length that's specified in the UDP header, then there may have been something wrong, and you may want to discard the message. The checksum also makes sure that nothing in the middle was tampered with, although if there's some sort of man-in-the-middle attack or something like that, a checksum is pretty easy to manufacture after you've altered the packet. So you can see here in the messages that there's a number of UDP packets. Some of them just say UDP. The one I'm looking at here happens to be from the Skype application talking to Skype servers. And we've also got DNS. Now, DNS also needs some fast response times because you don't want to spend a lot of time looking up information about the servers that you're going to before you just go to them. So DNS servers throw out their queries onto the wire using UDP, hoping to get fast responses. They don't want to spend a lot of time setting up connections and doing all of the negotiating that comes with a protocol like TCP, for example. So you see here that DNS is using UDP, and what we've got here is another UDP packet. Source port, destination port is the DNS port or domain port, which is 53. And at the bottom of Wireshark here, you see the domain name system query. If we open up the queries section down below, we're looking for a type A record, which means I need the IP address or just the address of the hostname con.skype.com. So that's some information about the user datagram protocol, or UDP.